In this video, we'll create a Python script that's going to harness the power of OpenCV coupled with some pre-trained convolutional neural networks and will allow us to estimate the gender and age of somebody within a picture. Our Python script is going to be under 100 lines of code, and by running our main.py file and passing it an actual image, we'll be able to estimate where the face of somebody is within an image, as well as what their gender is and the approximate age for them. And it's going to work for both male and female based pictures. So another example of this could be when I set the script to actually use a female image, and as you can see, it detected where the face of the female is, what the actual gender is, and what's the approximated range for the actual age that this person could have. As always, if you enjoy content like this, then don't forget to leave a like on the video and subscribe to my channel so that you get notified every time I release a new video. To get started with the actual tutorial, we're going to be implementing everything from scratch. So what I'd like you to do is just create an empty Python file that you're going to be running, and then that's pretty much all we have to do. The first thing that we're going to be doing is installing all of the dependencies that are required to actually make this script functional. And the only dependency that we're going to be using is the OpenCV Python package. And OpenCV is an excellent computer vision library, and it has a ton of functionality within it, some of which we're going to be using to actually create our system of detecting the face, age, and gender of somebody. So let's copy this pip install command. Let's minimize the browser, come back to our Visual Studio Code terminal instance, paste this in, and this is going to ensure that I install the specific dependency within my Python virtual environment. Or you can install this within your global Python development environment as well. Just depends on you. If you want a tutorial on how to set up a virtual environment on macOS and Windows, leave a comment down below letting me know, and I'll try my best to do that for you. As always, links to the resources that I mentioned within this video, as well as a link to the source code, can be found in the description below. So feel free to take a look at it if you're confused at any point. Now that we've actually installed all of the dependencies, the next thing that we're going to be doing is actually taking a look at where you can download the pre-trained models that are going to be used by OpenCV to then instantiate its neural networks. So to do that, we're going to be using this actual GitHub repo. A link to this will be in the source code's main.py file, so you can just download the source code and it'll show you that. And what we're basically going to be doing is downloading these files, which are the proto-text and cafe model files. And they are going to be a couple of these, so for age, for gender, and then for OpenCV face detector. So what you can do if you're using Chrome, and this is a very easy way of actually downloading files without actually pulling down a whole Git repo, is to install the git zip extension on Chrome. And then what that'll allow you to do is actually just have some UI given to you on GitHub, like these checkboxes, and then you can select these files, the ones that you specifically want to download, like so. And then it's going to show you this download button that you can basically click on. It's going to automatically take all of these files, zip them up, and then give you a zipped download, and then you can extract them and put them wherever you want to. But once you've downloaded the models, the next thing that you're going to be doing is basically creating a models folder within your actual root of your project. And then what you're going to be doing is just basically copy pasting in the actual models. So now I'm going to quickly copy and paste these model files in. And once this is done, that's pretty much all we have to do in terms of the setup. So now we can get into the good part, which is actually coding. So to get started, the first thing that we're going to be doing is importing our OpenCV module, and it's going to be import CV2. And once that is done, then we're going to be reading in an image. So to read an image, you can use any image that you'd like. What I'm going to be doing is using the actual images that I had used when showing you this tutorial. And these images are going to be available within the download for the source code as well, link to which will be in the description. So I'll just basically copy and paste these in. There we go. And now I have these two pictures. I have for female one and then for male. So the next thing that we're going to be doing now is basically reading these images in. So to do that, I am going to set a variable called an image and set that equal to cv2 dot, and then we have a function on this called imRead. And as the name suggests, this reads in an image. And then we can pass in the actual name for the actual file. So in this case, it's going to be male_1.jpg. And then with this done, we can move to the next step. So in the next step, what I'm going to be doing is just resizing my image, and this is going to make it easier for us to work with it later down on the road. So I'm going to do cv2.resize, and as you can see, this is basically going to resize an existing image. We have to pass in an image, which we already have, and then after this, the actual size. So I'm going to do 720 by 640, and this is just a size that I concluded worked best for the actual scenario that we're implementing. Once this is done and we've read the images, we can actually define the models that we're going to be using and then load them. So to define the models, it's going to be pretty simple. The first thing that I'm going to be doing is creating some variables which are going to store references to the actual location for the models which are under the models folder. So I'm going to create a face_pb txt variable, and this is going to, as the name suggests, hold reference to the model, which is under the models folder for the actual face pbt text files. So this is this one. Once this is done, I'm going to do face_pb and then set that equal to models / and then the actual pb file in this case, which is going to be openFaceDetector_uint.pb. Once this is done, I'm going to do age_proto txt file, and this is going to be equal to models, and then as the name suggests, it's going to be the age proto txt file, and then we're also going to have the age model, and then this is going to be models / and then we can do cafe model for the age. There we go. And then once this is done, the next thing that we're going to be doing is then setting the gender proto text. There we go, and then setting this equal to models / and then the gender proto text, and then finally we'll have the gender model and set this equal to models / and then gender_net.cafe model. There we go. So now that we've defined our models, we can actually load these up. So to load them, what we're going to be doing is basically utilizing OpenCV and then creating a deep neural network and then passing these model weights to it, so that then we can use that and give our image as input and then get some output from them. So to load the models is going to be pretty simple. The first thing that I'm going to be doing is creating 3 different models. One's going to be for detecting the face of the person. The next one is going to be taking in that face and then spitting out a gender. And the other one is going to be taking in the face that we've detected and then spitting out an age range for that person. So face is going to be equal to cv2 dot, and then we can do DNN, and then I'm going to do dot readnet. And then there we go. And then here we're going to pass 2 things. The first is going to be the face PB, and then it's going to be also the face PB text. There we go. Once this is done, I'm going to do for age. So it's going to be the same thing. So I'll just copy and paste it. And in this case, we're going to, for the age, pass in the age model. And then for the actual second argument, it's going to be age proto text. And then finally, I'll do for gender gen, and then set it equal to the same. But this time, to read the net, we're going to do gender model. And then here it's going to be gender proto txt. There we go. And now that our models have been loaded, what we can do is actually run the script to make sure that it works as intended and that we get no errors. So to do that, we can do Python and then main.py, press enter, and let's see if it works the way I'd like it to work. So it's going to take a little bit of time initially to load up these models and do everything that's required, but hopefully the script should exit without any issues. So I'll pause the video and then I'll resume it once the script has finished its execution. Welcome back, everybody. So as you can see, the script finished its execution successfully. So this means that we can be sure that everything was configured properly and that our models are being read properly. So now that this is done, the next thing that I'm going to be doing is basically setting up the actual labels, or you could say classifications, for what the actual age ranges and genders are going to be. So for that, I'm going to say that we're going to be now setting up classifications, and then I'm going to just paste these in. And what I'm doing is basically defining the age classifications, like so. And then we are going to do the gender classification. And what's basically going to happen is as follows. Our AgeNet, you could say, is going to take in an image as its input, and it's going to be actually a vector, and I'll show you how that works. It's going to then do whatever it needs to do and spit out to us an actual number. That number is going to correspond to an index within this actual list, and whatever that index is going to be the age range for that person. And similarly for the actual gender one, it's going to be the same thing. It's going to take in an image, it's going to spit out an index. That index is going to correspond to a specific index within this actual list that we see here. And if it's index 0, that means it's a male. If it's index 1, that means it's a female. So with that said, we can move on to the next part. So as a good practice, what we should always do is when we actually read in our inputs, what we should do is make a copy of them and perform whatever operations we need to do on them so that we do not change the original data. So to do that, I'm going to do the following. I'm going to copy the image that we had read in, and I'm going to create a copy of that and put that under a variable called image.cp and set that equal to image.copy. Once this is done, now we're going to be getting some parameters which are going to help us with the later steps, and those are going to be getting the image's height, getting the image's width, and then converting our image into a blob. And you could think of blob as a vectorized version of our image so that we can feed it to these different networks that we've created. So now that this is done, let's do this. Let's get all of these parameters. So I'm going to do get image dimensions and blob And then I'm going to do the following. I'm going to set the image underscore h variable, which is image's height, and I'm going to do image CP. So what I need to do is get the shape of it, and then the actual 0th index is going to be the height, and then for the width it's going to be the same. I'm going to do image underscore CP dot shape, and then the first index is going to be the width. So to actually show you how this looks, I'm going to do the following. I'll just print image underscore CP dot shape. And once we do this and do command save and then run our script, you're going to see that it gives me the following output, which is 640, 720, and 3. So when we resized our image, you could see that we set 720 for the width and 640 for the height. That's being reflected here now, where in image.say we have 640 and 720. So 640 is the height, 720 is the width, and then this is actually a 3-dimensional vector. So now that this is done, we can move on to the next step, which is to actually, just for the sake of it, print the image as well. So if you do this, you're going to see that we get this vector printed out, and the vectorized form here is actually a list which contains lists, and this could be infinite dimensions. But in this case, we have a list that contains lists of lists, if that makes sense. So now the last thing that we're going to be doing is actually taking in our image and then converting that into a form that the actual neural networks that we've created can ingest. So to do that, we can do cv2.dnn, and DNN stands for deep neural network. I believe that's what it is. Then I can do blob from image. And then here we're going to pass in some parameters. The first is going to be the image. So I'm going to do image.cp. So we're passing in the image's copy. Then there's going to be the scale factor, which my testing concluded 1 is good. After that, we're going to set a size. So this is not the size of an image. This is actually the size of what our neural network is going to take in for its inputs. So it's going to be 300, 300. And then once this is done, we're going to give it some mean values. And don't ask me what these mean values are, to be honest with you. I had to do a lot of research and find a couple of different mean values. And then for the testing that I concluded, I found out that these mean values were good enough for my use case. So these are the mean values that we're going to be using. I'm going to create a variable called model mean values and set that to a list which contains 104, 117, and then 123. So let's copy this, come back, and then paste it here. And then once we've done this, the next thing that it's going to ask us for, should we swap the R and B channels? I'm going to set that to true. My testing concluded it was good. And then let's do false for the last one, which is, are we going to crop anything? No, we want the full image. So there we go. With this done, that's pretty much it. So now what I can do is do print and then blob. And now you're going to see what the input for the actual network is going to be. So let's clear our terminal, python main.py, and there you go. Now the actual image has been converted into a vectorized form, which is going to be consumable by our actual neural network. So now we can use the neural network and perform some crazy things. So the first thing that I'd like to do is detect a face within the image, because once we have a face, then we can crop that face out and then set that face to the other two neural networks, which is for detecting the age and the gender, and then they can give us a gender and an age as well. So let's do that. Let's get the face first. So to do that, it's going to be as simple. We are going to take our face, which is, if you remember correctly, a neural network that we've created. And then I'm going to do set the input for that. And then I'm going to do blob. And once this is done, now we're going to basically do the following. We'll save the output or the result that we get from the actual network within a variable called detected faces, and then set this equal to face.forward. So to run the actual network and give it our input and then get the output, we do face.forward. And then what we can do is actually print detected faces, and let's see what this is. And instead of printing the whole thing, let's do detected faces.shape, and let's see how many faces we get. I assume it's going to give us a couple more, but then we can go through the confidence values and determine which are actually faces and which aren't. But let's do this. And as you can see, it's giving me 11207. So we've detected something. We can move onwards with this and actually see what it is. But let's move forwards. And just to let you know that the actual output here, which actually states how many faces were found, is actually the second index within this actual set. And it's telling me that there are 200 faces, but it's not, it's just one face. It's just that it's detected a bunch of different squares. And now we're going to look at the confidence value to determine which are the ones that are actually faces and which aren't, not the ones. So to do that, we're going to do the following. Now that we have a bunch of detected faces, we're going to create face_bounds as an actual list, and it's going to start off as empty. Then I'm going to go ahead and loop over the faces that we found. So I'm going to add a comment, which is going to be draw a rectangle over faces, and then it's as follows: for I in range, and then we're going to do detected faces dot shape, and if you remember correctly, the second index is how many actual faces we've detected. So with this done, then I'm going to do print, and then I'm going to print each of the face. So we can do detected faces, and then I'm going to do 0, 0, ith, and then that's pretty much it. And then once this is done, let's actually see what we get as an output. There we go. You can see that we get a bunch of different lists printed out, and each list corresponds to a face or a detected face or a face bound you could think of. And here we have a bunch of different values within it. The value that we are concerned with is at the second index here, which is the confidence level of the network as to how confident it is that the thing that it has found is actually a face. So as we go through the list, the confidence decreases, but here you can see that the first entry is around 99% confident, because 1 means 100%. So it's 99.9% sure that this is actually a face, and then this just kind of like tapers down and decreases. So now what we have to do is basically use this value. So let's do confidence is going to be equal to detected faces, and then the second index, there we go. And then we can do if the confidence is greater than, and then you can set a threshold here. Let's do 0.99%. So 99% confidence or more, then we're actually going to do something. Otherwise we won't. And if that is the case, then we are going to print our detected face. And let's copy the same line here, paste it in here like so. But this time I'm going to do as follows: save, and let's test the script out once more. But this time, hopefully, we should just get one list printed out. There we go. So the face bound, which was 99% confidence or more, there only exists one of those. So we've printed that out. So there we go. Now this is looking good. And now what we're going to be using is using the third, fourth, fifth, and sixth index correspondingly to determine what the actual bounds of the rectangle are on the X and the Y axis. So just keep with me and you'll understand what it is. But now what we're basically doing is getting the X coordinates and the Y coordinates so that we can create a square or a rectangle, which basically defines the bounds of the face that it has detected. So to do this, it's going to be as follows. I'll create a variable, call it x1, and I'm going to set that equal to, and then we're going to do detected faces, and then 0, 0, and then we can do the third index, and we're going to multiply this with the image's width. There we go. And this is going to give us the actual x1 coordinate. Then to get the x2 coordinate, it's going to be the same thing. I'll just copy and paste this. But this time the index that we're going to be using is going to be 4. There we go. Then let's copy this and paste it 2 more times. And this time the other one is going to be y1 and then y2. And then here we're going to do image underscore h, and then here we're going to use the 5th and the 6th index corresponding to the actual y1 and y2 values. So now we have this x1, x2, y1 and y2 values that we can use to map out a rectangle onto the actual image. So to do this, we can do the following, which is to do cv2 and then dot rectangle. And what this function allows us to do, as the name suggests, is draw a rectangle. I want to draw this actual rectangle on our image. So if you remember, the image was the image copy that we had created. So there we go. And then the coordinates are going to be x1, x2. And then it needs y1, y2 coordinates as well. So let's pass those. And then after that, we're going to pass the color. So the color is going to be 0, 255, 0. And then after this, I'm going to also define the actual width or the thickness of the line. So I'm going to do int. And then I'm going to call the round function within it. And here I'm going to do images height divided by 150. And then finally, the last thing that we are going to be doing after this is specifying the actual line type, which is going to be 8. So let's do save. And now let's just quickly run our script and make sure that nothing's broken, and it's giving me an error. So I figured what the issue was. The actual indexes that we're storing for x1, x2, y1, and y2 are not integers. So we just need to make sure that these are integer values. So I'll wrap these within an int call, and this is going to convert the output into integers, making sure that Now it works as intended. Yeah, our script is working as intended. So now that we've actually drawn a rectangle onto our image, what I'd like to show this image to you so that we can visualize where the rectangle was drawn. So to do this, we can do the following. We can get out of this for loop, and then we can do the following, which is cv2.imShow, as the name suggests, shows an image. And then I'm going to say that the name for the window is going to be result. And then here we can do image cp. That's the image we had drawn our rectangle on. Then I can do cv2.wait for a key. So don't just show us an image and then exit out. Give us a moment to take a look at it. And when we press any key on the actual image, then just proceed forwards. And then I can do cv2.destroy all windows so that it destroys the things that it's showing us. And now we're ready to test it out. So let's do. And there we go. It detected the face correctly, as you can see. So with this done, what I am now going to be doing is basically showcasing to you guys what the next step of the process is going to be. So in the next step, we need to take this face, the cutout that we've gotten, and then save that within some list, and then take these face bounds, pass them to our age and gender networks, and get the gender and age from there. So now when you are clicking on this image, you can click on any key and then it'll exit out, and there we go. We can move forwards. So what I'm going to be now doing is within the for loop, if the confidence is greater than 99%, then besides drawing a rectangle on the actual image, I'm going to add the actual bounds to a list which I've created, which is called face bounds. So I'm going to do face bounds.append, and to this I'm going to append a list which is going to contain x1, comma y1, and then x2, comma y2. So it's going to contain these coordinates which we're going to be using later on. So now with this done, let's give our script a run. Everything looks good. We can move on to the next part. So for the next part, now that we have these face bounds, we are going to be using them to extract some information about the face from the image. So extract the face out of the whole image and then send that face to our networks. So I'm going to do for the face bound, in face bounds, we're going to do the following operations. I'm going to use a try except block first. So let's do try. And then let's create the except block first, because there might be cases where an exception might rise. So we just like to handle it instead of crashing our script. I'm going to print the error, and then I am going to say continue. So the first thing that I'd like to do is use the face bounds and then extract the face from our actual image. So to do that, I'll do face is equals to, and then I'm going to do image underscore cp. And then I'm going to, from this actual vector, extract the relevant data which corresponds to the face. So to do that, it's going to be as follows. I'm going to use the max function, and then I'm going to go 0, 2, and then I'm going to do face bound. The first index is x1, if I remember correctly, and then minus 15. And these constant values that you see here just are values that I use, which I found work good with the testing that I'm doing. And then here, I'm going to take the information from this index to the next index, which is going to be min, and then face bound, and then the third index, which is going to be the x2 plus 15, and then that's pretty much it. And with this done, what I'm going to be doing after this is adding a comma, and then I'm going to do image underscore cp dot shape, the 0th index, and then -1, and then do save. And this seems to be working as intended. So now what I'm going to be doing is getting the y. So for the y, it's going to be the same thing. Firstly, I'll copy this, paste it in. But this time we're going to go from 0 to face bound, and then I am going to do the following, which is the 0th index. So, and then I am going to do the x-axis min, and then just copy this once more, paste this again. And this time I'm going to do 2, I believe. And then everything else seems to be the same, I believe, except for this is going to be 1. And that's all we had to do. So this code is going to allow us to extract from the image the relevant part that corresponds to just our face. And with this done, I'd just like to quickly mention that the first part refers to getting the actual y-axis, and then the next part refers to actually getting the bounds on the x-axis. So now with this done, we can actually print the face and see if this is actually working the way we'd like it to work. Yep, kind of looks like it's working, and it's giving me an error for the face being an empty list. So let's actually move forwards with this and let's see what actually happens, and then maybe we could see what the issue is. So now the next thing is going to be to take this face and then convert that into a representation that can be given to our neural networks. So for that, I'll do cv2.dnn, and then I can do blob from image, and then here we're going to give it our face image, and then we are going to, after that, say that the scale factor will be 1.0, and then the actual size is going to be 277, 227, 227. And then after this, we're going to pass in the same model mean values, and then for swap R and B, it's going to be true in this case as well. And then that's all we had to do. So with this done, let's actually see if it works. Seems to be working, so let's continue and let's see what actually happens. So once this is done, I'm going to do the actual gender identification first. So I'm going to do gen.set input, and then we can do blob. And then to actually get the output, I can do the following, which is to gender prediction, and then set this equal to the gender dot forward. So now let's run the network, and then we can actually print the gender prediction. And that's pretty much all we had to do. And I'm going to just quickly fix the variable naming. There we go. So let's do save, and then let's run it. And it's given me an error. So let me see what the error is. It says that sssize.empty is function resize. So let me take a look at it, and then I will resume the video. Welcome back, everybody. So I figured the issue out. What was actually happening is that we were actually saving the actual x1, x2 values and y1, y2 values for the actual rectangle in the wrong variables. So what we need to do here is that it's going to be x1 is equals to this, and then y1 equals to the following, and then it's going to be x2 is equals to this, and then y2 is going to be the following, and then the other change is going to be that for y1 we're going to do image.height, and then for x2 we're going to do image width. I believe that should be good. And then the last thing that we need to do is for the actual rectangle draw function, it needs to be x1 and then y1 as the actual values, and then it's going to be x2 and y2, and then that's pretty much it. And then for the face bounds, we're setting the actual list in the proper order. So everything seems to be working. So now what we can do is actually go ahead, clear this, and then do python main.py. So there we go. Now the actual face is dead in the middle of the actual square, and it seems to be working as intended. So that was a little hiccup, but all we did was just modify these actual variables to refer to the correct index, and then actually extract the x1, y1, x2, y2 coordinate for the actual rectangle, and then show that. And then all of the logic other than that is the same. So what we're now going to be doing is then printing the gender prediction. So as you can see that for the gender prediction, what we get as an output is this list that contains a list that contains two values within it, one at the 0th and the 1st index. The 0th index value basically refers to how confident does the network think that this is a male's image, and then the 1st index is for a female. So now to get the actual gender prediction in the form of a text, what I can do is as follows. I can say that the gender is going to be equal to, and then we'll access our gender classification, and we need to get the 0th index or the 1st index. So what I need to do is basically determine which index is going to be having the biggest value. So in this case, it's index 0. Sometimes it might be 1. So a good way to do this is as follows. We can take a look at our gender prediction, then go into the 0th list, and then within this list get the index of the child, which has the biggest value. We can do that by doing argmax, like so. And I believe this should work as intended. So now we can do print gender, and hopefully, fingers crossed, this doesn't declassify. There we go. So it says male. It's looking at the picture, looks good. So now that this is done, the process for actually determining the age is pretty much the same. The first thing that we have to do is basically do age.set input, And then I'm going to say that we can use the same blob. Then we're going to do age underscore prediction, and then set that equal to age.forward. And then I can actually print this for you as well, but this is also going to be a multi-dimensional array. And what we can do is basically print age, and then we can do this. As you can see, it gives me this out. I need to do age prediction actually, so let's do this again. As you can see, it gives me an output of a list that has a list within it, which contains all of these different values at different indexes, each corresponding to how confident does the network think that the age of this person is within the specific bracket. So now what I can do is the same thing that I've done before, just get the index of the largest value within this actual list. So it's going to be as follows. I am going to do that the age that is going to be of this user. So we can do age is going to be equal to, and then I can do age classifications, and then I can do age prediction 0, and then the same thing, which is .argmax. And then we can print the age just to check and see what it tells us. So it's going to give us a estimate. There we go, 38 to 43. Seems about right, so we can move forwards. Then the last thing that I'd like to do is take this information, put that onto my image. So to do that, I'll do the following. I'll do cv2.putText, and then it's as follows. I'm going to do image cp. So this is the image that I like to put the text on. The actual text, so this is going to be an f string, just basically allows me to embed variables within the string. I'm going to say we're going to have a gender, then a comma, and then the age, like so. Then once this is done, we have to define where it's going to be. So for that, I'm going to do the following. I'm going to do face bound, and then the 0th index, and then face bound, and then the first index, which corresponds to the y1 value, I believe, plus 10. And you can add or subtract from this to actually move the text. There we go. Then after this is done, it requires us a font face. So I can do cv2.font, and we can do font Hershey complex. You can use whatever you want. I'm going to do Hershey complex. And then after this, the actual font scale 1, then the actual color, I'll do 0, 0, 255. And then I can do the actual thickness as 4, and then the actual line type, which I can do cv2.line AA. And then that's pretty much all we had to do. So with this done, it's going to go ahead and put this text on our image. And then we already have the logic for showing the image. So it should work as intended. So let's do python main.py, and there we go. It's telling me that it's male 38 to 43. And then the actual rectangle indicates where the face is. So now let's test this out with the female as well. For that, I can do female underscore 1.jpg, and then we can do there, and there we go. It says female, and then 25 to 32. So the last thing that we're going to be doing is just adding some cool error handling, and then that's pretty much it. So to do that, I can come to the point where we actually take the face bound information and add that to our face bounds list. And then here, before proceeding with the rest of the script, I'm going to say if not face bound. So if there are no face bounds is empty, then we're going to say print, and then we can say no faces were detected. And this way, if you pass in an image that doesn't have any faces within it, it's not going to error out, and there's going to be a graceful exit. So now with this done, what I can do is just basically exit like so, and that's all we have to do. So let's give our script a final run to make sure that it is working as intended. And it is. So there we have it. This is how you create a Python script that harnesses the power of CV2 plus some convolutional neural networks to tell you what the age, gender, and where the face of somebody is within an image. As always, if you enjoyed the video, then please don't forget to leave a like on the video and subscribe to my channel so that you get notified every time I release a new video. And as always, stay happy, stay healthy, keep learning, keep growing, and I'll see you guys in the next video. Bye-bye.